Welcome. In this session, we will look at another example of determining intervals where a function is either increasing or decreasing. This again is a continuation of a previous example. For the function x power 4 thirds minus 8x to the 1 third, we found the derivative, simplified it, factored, and found where the critical values are. The simplified derivative is 4 times x minus 2 over the quantity 3x power 2 thirds. The derivative is 0 at 2, it's undefined at 0. The domain of this function is again the entire real line from negative infinity to infinity. So if you look at the intervals where f prime has a fixed sign, when we start at negative infinity, we don't hit any zeros of f prime or critical values, undefined points on the graph of f prime till we come to 0. So that's the first interval. From 0 next we come to 2 and then finally 2 to infinity. Again we will determine that signs by using test values, although in this case that's a little bit of an overkill because the denominator 3x power 2 thirds is positive except at 0. So the sign of f prime is determined by the sign of the numerator x minus 2. Of course, we can also do it the long way. Pick some test value in each interval, plug that in. So it's negative the first two intervals and positive in the last interval. We want to determine where the function is decreasing. That's equivalent to f prime being negative. And that gives me the intervals negative infinity to 0 and 0 to 2. So these are the intervals where f prime is decreasing. Now, there is one small point that I haven't talked about before. The distinction between a function being decreasing in some open interval and some closed interval. If a function is decreasing in some open interval and it's continuous at one of the endpoints, then it will be continuous even when you include the endpoint. We won't usually belabor this issue. I won't really care if you put down an open interval or closed interval. But when you are doing the homework, the online homework, it might matter. And it specifically matters in a situation like this, where a function is decreasing in two contiguous intervals. If the original function is not continuous at the common endpoint, then you cannot combine the two intervals. But if it is, you can, and you may be expected to do so in the online homework. So in this case, we have two contiguous intervals. It is having a common endpoint where this function is decreasing. And this original function is also continuous at the common endpoint, namely 0. So I can combine the two intervals. So we can say the function is decreasing in the interval from negative infinity to 2.